Okay, welcome everyone to the Future of Tech and Bio. Josh, Bob, thanks for coming today. To set the scene a little bit, you're both investors in my company, Gameto. So can I just ask, if I ask you some difficult questions today, would that not affect any further due diligence process? Are we okay? We agree?
We're good. We'll see.
Okay, well, let's dive in. We do have quite a lot of exciting topics to discuss. I guess the first question I'd like to ask you, you're both quite interesting in a sense that you both invest in companies, but also create and launch biotech companies. And as we're seeing the volatile times of biotechs, where do you think the trend is going? Which model is better, whether a biotech venture studio for building successful companies, and what are the implications for the infrastructure of funds? Do you need more entrepreneurs in residence or operators versus financial generalists? I don't know, Josh, do you want to start?
I think in the current environment where, like you said, market volatility, vicissitudes, being able to put a company de novo in business to license intellectual property from a university, government lab, put scientists in business, reduce the human capital risk and put a management team and reduce the syndicate risk and get financing packaged and give folks 30 months of cash so that they have 2.5 years to hit milestones, keeps them relatively protected in an insulated bubble, not a hype bubble, but like a protected bubble from whatever is happening in the macro, whatever is happening in the micro. Anything that we've done at Lux in de novo company creation, I literally learned from one of my partners, Larry Bach, and from Bob. I mean, these were like the kings of, and are the kings of de novo company creation, finding the cutting edge coming out of Science and Nature and Chemical Engineering News and PNAS, finding the principal investigators, persuading them that they should put their life's work entrusted into their hands, and then recruiting the creme de la creme and then doing it time and time again. So, I mean, Bob is truly like the king of de novo company creation, and I think without a lot of the companies that you've created, there would be life-saving drugs that today are not on the market. So you are often quiet and humble about this, but I truly think you're a master at this.
I don't know what to say. Thank you. I think biotech is a science game, and there are rights and wrongs. And the biggest, and when tech investors ask, what's the difference between biotech and tech? It's, technology matters in some disciplines. A lot of times it's number 2, number 3, number 4 on the list. And in biotech, it's number 1, number 2, and number 3. Nobody wants the second best cancer treatment. So incubating companies takes the nucleating scientific event first. So it's very difficult to say we're going to go kind of discover a new thing. You can do it, but it takes a lot of money. So we've had both kinds of models where we'll go into a space and say there's a huge problem. We're going to throw a lot of money at it with multiple scientific approaches to try to discover which one might work. Or we're going to have this invention, scientist invents X. Gene editing is a great example of that. There's a new kind of editing tool. You convince scientists to do a company, and then you kind of invest sequentially in a classic venture model. Very different scales. Sometimes these kind of models where you're going after a big problem, say Alzheimer's or aging or rejuvenation, those take literally hundreds of millions of dollars. It's very, very difficult to do a $2 million or $5 million experiment when you're trying to kind of ferret out the new technology.
There's two pieces of this, by the way, the human capital piece and the financial capital piece.
Yeah.
The financial capital piece, which Bob was just alluding to, is, in tech you can do historically, forgetting about recent valuations that were aberrations, $5 or $10 million Series A at a 10 or 15 pre-money valuation, a 20, 25 million post, you could buy 20% of the company or more, and you would hit a milestone and then go out and raise money at a higher valuation, having reduced risk and created value for another investor to provide a lower cost of capital. We're going to have a company that I think gets announced in the next month or two. The seed or Series A or founding round is 160 million. And this is just a different scale because you are providing, again, that capital for these companies to be insulated. You're sending a signal that this is going to be the dominant platform. And that's important for the human capital piece, which is one of the crazy phenomenons which is observable throughout history, from invention of television, Darwin versus Wallace and the original publication of theories of evolution is that science happens contemporaneously and competitively. Something happens in the air, so to speak, that the time is ripe for ideas to be combined, and then they surface. And so part of our job is not only identifying the PI, the principal investigator, the scientist, but convincing multiple people who might be working on the same thing to subjugate their egos and be part of one platform instead of creating 5 different competing companies.
Absolutely. Okay, so you've answered kind of my next question that biotech, considering a lot of the R&D is upfront, perhaps requires larger financing. And it seems, Bob, from what you've said, is that you kind of go where the science takes you. You touched upon a very important point, Josh, or like how do you convince people to join this critical mass and reach this critical mass to create and become the leading company in a field? And one kind of novel aspect that hasn't really been explored as biotech is something that you've launched recently. You've launched the Lux podcast, which has been one of the most entertaining podcasts on release on Saturdays, where you really discuss the deep tech, but in simple terms that everybody can understand. And yesterday we had the panel on biotech, and kind of the main conclusion of the panel was that this biotech revolution is not being televised. We didn't even know that gene therapy for a rare disease reached the clinic. So how do you think media can play a role in this to potentially attract more people to biotech, perhaps increase investor interest, or potentially even increase the total addressable market because people will become more educated about some of the health or bioproducts or medicines out there?
Yeah, in a sense you answered it in the question, is that I do think that we are storytelling primates, and particularly when people don't understand the cutting edge of something that's new, and you think about quite literally the stories that are told. They're first scientific stories that are told if you take CRISPR, and then there are these human interest stories about like something like CRISPR, and you have Jennifer Doudna, and you have Feng Zhang, and you have Walter Isaacson, writing a book, and then people are making movies out of it. And so these things sort of reach the masses, but long before they reach the masses, they are in the pages of Science and Nature and PNAS, and they are greedy, selfish, motivated capitalists that are trying to find these stories and identify them, license them, start companies around them before other people know them. And I also think that there's a role to play in truth-telling, which is there's so much hype out there around so many of these areas that you also would like to avoid misallocation of capital, and you don't want hucksters and fraudsters raising money, or if they do, you want it sort of subtly pointed out so that they don't continue to, because that hurts fields. There's an enormous amount of work, obviously, in liquid biopsies, which today are becoming more serious again, but it took a big hit because of Theranos. And so you want to sort of out the frauds, and you need investigative journalists looking into these things, and you also need serious credentialed scientists, writers, and authors, and people doing podcasts to surface the stories that are worthy of being celebrated. And again, late partner Larry Bach always said that as a culture, you get what you celebrate. And I certainly want to live in a society where we're celebrating scientists who are dedicating their life's work, whether it's out of greed or ambition or vainglorious or vanity, to advance the human condition, to discover things that we never knew and reduce the boundary of ignorance of what we don't know.
And speaking of the areas of science you're mostly excited about, Bob, let's start with you. We had the panel on cell and gene therapy yesterday. You recently launched a massive aging company. Is aging now becoming a field of biotech? What are the areas of biotech you're mostly excited about that you're going to think
He
you're
is,
gonna
by the way,
change?
he's 94 years old. Yeah, amazing.
I think hands down for me, even though I'm super excited about gene editing and machine learning and some of the other tools that you can use to make things go faster, it's really just epigenetic reprogramming and the idea of rejuvenation, that you could not think about anti-aging anymore, but you can actually think about taking a cell and turning the clock back and making disease go away, and then maybe taking an organism and turning the clock back and making you young again, essentially. And when you're young, again, you don't get the diseases that you would have gotten when you're old. So it's kind of a mind blower, and it takes a while to accommodate like what the implications of that are. But if you think about the reactive healthcare system we live in, it's all about like hospitals and doctors reacting in mostly a fairly poor outcome way to your disease. If you ask your doctor about any of these things, they're not trained in how to live longer or even the idea that you can take the clock back. So when you think about what's the first kind of trillion-dollar healthcare company going to look like, it will disintermediate hospitals and it will disintermediate pharmaceuticals. And the way to do that, and we spend $3.5 trillion a year, just to remind everybody in the tech world, like healthcare is actually bigger than tech. So we spend 3.5 trillion in the US, maybe 4 on healthcare, 6 or 8 trillion worldwide on this reactive system. Maybe 500 billion is proactive. And so imagine a system where you can actually turn back the clock in centers that could rejuvenate a healthy human, or if you have disease, that you could just shut it off. And I think that's actually where we're going to head. The science is promising. Actually, Dina is an expert in this space. It's easy to understate what I think is going to happen just following this biology.
I'll add a few areas. I mean, again, we take these things for granted. You're in the fertility space, but my cousin best friend, had 2 babies with 2 egg donors and 2 surrogates. As an independent man, that's something that would have been science fiction 2 generations ago. It's astounding, let alone same-sex couples and the kinds of nature of the modern family that has evolved because of science. And first test tube baby, 1977, 1978, thereabout. So it's just really astounding in a generation just in that field. Current areas that we find fascinating: chronobiology. The idea that the cells that are on your skin are regenerating relatively rapidly, the cells in your gut are regenerating rapidly, your Purkinje cells in your brain may be 25 years old. There's a biological age for you, and then there's a chronological age, and those are different. And it has implications in cancer and metabolic disease and elsewhere. People that live together may get in synchrony in their biological clocks around certain things. And so that's an area where being able to intervene, engineer, disrupt the biological clocks that we have, not just for reproductive health, but for cells and aging is fascinating. We had started a company that was really inspired by a crazy X-Men sci-fi idea, which was a company called Variant Bio. And they don't like when I say that we're looking for mutants, but quite literally, when you think about most of the sequencing for the past 20 years, it has been pale male, stale white Europeans. And they had the insight to say, well, what if we went to the outlier parts of the world to find outlier people with outlier traits, people that get into accidents, their bones don't break, they can use very little oxygen at high altitudes, they can dive deep depths, they can eat fatty foods and not get fat, they can drink alcohol or smoke cigarettes and not get liver disease or lung cancer. And so these protective variants, and that's an area that I think is very interesting, of finding closely related populations that have been neglected and finding monogenic conditions that could be druggable targets to bring back to the masses. Another area is scientific instruments and tools. I am very bullish, both for geopolitical reasons, on a great new race between countries for the prestige that comes from winning Nobel Prizes and significant scientific medals. And that often comes because discoveries come from instruments. And so whether that was X-ray crystallography that led to understanding DNA, or cryo-EM, which is a way to have atomic resolution of molecules today, and new techniques, lattice light fields that let you see inside of cells in real time. These are all new tools that give people either a monopoly on enhancing researchers' productivity or in discovering drugs. So those are all areas that I think are ripe for interesting talent and capital to flow into.
That's very great introduction to the next question. We talk about now we're in the golden age of biotech, but historically the data was, 9 out of 10 drugs fail. And if you look at some of the statistics, there's like a trend towards increased success rate post phase 3 to entering the clinic. But what is the technology that we're building to enable us to be better at drug development? You invested in a company, Josh, Benchlink, right? We use Benchlink to help us standardize data collection in clinics in the US and Spain. It's already ensuring our data is better and hopefully our therapeutics will be better. But what are the other things that you're thinking about? And are we really getting better at drug development if we truly want to build new drugs faster and better?
And so in Benchlink's case, it's software. It's for LIMS and ELNs, lab information management systems, electronic lab notebooks. But increasingly, it's sort of crazy in 2022. You go into these cutting edge buildings that billionaire donors have given to some of our great institutions, and you still have people, white lab coats and clipboards. And so there's a lot of robotics, automation, software that is coming into these systems. And that's another big area in the productivity of at least early preclinical research, where increasingly, in the same way, if you were a musician, you would go into a studio and rent time on it, and have to physically go there. And now you can pull up GarageBand and Pro Tools and Logic and basically design a song without the instruments. A lot of that stuff will increasingly be virtualized in scientific labs, where you can be on the beach in the Bahamas, pull up your iPad, run an experiment in the cloud lab, which is entirely run by robots, and that is happening now. So I think that's going to increase productivity. Software will increase productivity. One of the great things that increases productivity is lots of institutions interacting together. It used to be a single author or 5 authors or 4 authors from a single institution on a paper. Now you see 30 or 40 authors from multiple institutions. Geopolitics may slow that down in some inter-country collaborations. And then, as Bob noted before on the artificial intelligence and machine learning piece of this is sort of a buzzword that on one hand some people throw around, but I think a lot of our companies are using this to try to advance the speed and the processing that normally many humans would do, that you're able to do in a very compressed period of time.
Bob, anything you'd like to add on platforms or diagnostics that you're building?
I think if you think about editing, that's pretty precise. It's getting more precise. It's more deliverable, more targetable. So I think the hit rates will go way up on both rare and common diseases that might be subject to at least understanding where the mutations are to be fixed. And then on the ML side and AI side, I think it's the power of data. I think we're just getting the little bit of tease of how powerful that could be. I don't think any of us really know the exact path that it's going to happen in drugs, but we're kind of playing around with some technologies that have been developed, and I think one of the things that folks like the government and Google and Microsoft have figured out is that there are really unexpected benefits of scale that in complex systems that really I guess they're unexpected, right? And so things move faster than you think. So I think that will be an interesting thing to explore. We're exploring it on both creation of molecules and understanding of systems in terms of how you might target things in a more effective way to make medicines.
And coming to making medicines, Bob, you co-founded Resilience, and both of you are doing quite a lot to ensure that we, as the United States, remain the world's leading power in terms of biotech. Yesterday, we had the executive order. What are we doing and what should we be doing more to ensure we have vertically integrated essential medicines, preparedness for pandemics, highly skilled STEM workforce? I don't know, Bob, if you want to start, and we'll hand to Josh.
Well, I think, we all experienced the pandemic, so we kind of get version 1 of that. We had a little taste of version 2 with monkeypox. We actually can't make a good monkeypox vaccine in the US. So all you have to do is just rerun these experiments with COVID that was killing children, or monkeypox that was engineered, and you can think about, losing control really quickly. And how many scenarios have we done where there are 2 pandemics or 3 pandemics at the same time? One created by a Harvard graduate student, one who thinks there are 50% too many people in the world. So I think these things will be seen with more frequency, and right now we can't make most of those things domestically, so we definitely have to think about it kind of like we thought about the CHIPS Act, and how do you make things better, faster, cheaper, more systematizable, more accessible, not just to people in the US, but to the rest of the world. So we're in the early days of that. Whenever we show some of our, biotech advanced facilities to people in tech and even old-style manufacturing, they just shake their heads, at how antiquated our biologic systems are. So there's a long ways to go. But I do think it's super important from a national security perspective. It is going to be the problem It's not just like we're going to be done with COVID and then move forward to no threats. The threats are going to be more frequent, more intense. Everybody in the world is working on viruses now. The technology is much more accessible and automated, so it will, if you start doing the math of how many people can access the technology that are biology undergraduates and graduate students, how many of those people are crazy, how many of those people think there are 50% too many people in the world. You get to 12 monkeys pretty fast, and you end up with a few thousand people in the world who probably are capable, have intent, and want to do bad things. And so we have to actually think about those things in advance. You can't think about them in arrears.
On the manufacturing side, and Bob is being both discreet and humble about it, but we're investors in a company that Bob really created. And without giving details or specifics, because I don't know if it's ready to come out, in full, but billions of dollars have now been invested. The scale of this is not, Bob setting up a handful of people and saying, let's go develop some molecules. It really is, how do we rebuild the manufacturing base for biologics and small molecules and drugs and proteins, and I think it's going to be historic.
Okay, and the final question of the panel, although we could go on, it seems that the pace of biotech innovation has never been faster, but both public and private valuations are getting lower. How will this play out, Josh?
What we are doing, aside from what I call the bubble strategy of putting people in 30-month bubbles and giving them enough cash, there's a second strategy, which is anti-bubble, which is late-stage businesses you can invest in at early-stage prices. But the third, which I'm most excited about, is consolidation. And one of the companies that we've talked about before is Icon, E-I-K-O-N. This is a company that in a few years had $620 million of cash on the balance sheet, is out raising another $1 billion now. And you think, well, that's a lot of money for an early stage company, and Nobel Prize winning technology, Roger Perlmutter, who ran Amgen and Merck R&D, incredible team. There are 800 publicly traded biotech companies. Half of them have less than 2 years of cash, and 150 or so are negative enterprise value. And so if we're on a board of a publicly traded biotech company with 10 programs, I can assure you that that board meeting is basically how are we shutting down to 1 or 2 priority targets, and what are we doing with the other 7 or 8 targets, and we're either divesting them, mothballing them, licensing them, or something. And so I think people like Roger at Icon who have cash at a time when others don't are going to be in a position where you're going to see a lot of consolidation. So I would expect you're going to see a lot of M&A. Pharma will be a little bit slow to move, but you'll start seeing deal pace activity pick up. It will be on buyers' terms. You'll probably see some non-natural private equity investors start to get more involved. And then I think some of the companies that have these war chest balance sheets with great management and celebrated science will just make a killing.
Bob, what are your thoughts? Will the IPO window?
I think it's a barbell kind of market where the really great long-term technological movers are going to be above the fray here, and the long money will continue to come into it. Then in the middle, you'll get consolidation, and a lot of people confuse price and value and biotech in these markets. And so I do think that if you keep to the long-term thinking about what's the disruptive change that can influence medicines, right? You win by curing people or preventing disease or detecting disease early. You just keep those fundamentals. That actually powers through these cycles. In the short term, I think you'll see some rotation. And days like this, if this keeps going in an inflationary environment, where do you put your money? You probably put it in healthcare, actually. So there tends to be a rotation back into predictable returns. Whether that means that it will be kind of frothy, I think then it won't be as frothy. But at the top end, you'll still see some big valuations.
All right. Well, thank you for providing infrastructure, supporting entrepreneurs in this field, and creating biotech companies that are changing and saving the world.
Thank you.
Thanks, everyone.
Thanks, Dina.